Next thing I'm going to talk about is called angle of elevation. Angle of elevation is just a measurement of an angle starting from a flat line, like the ground or your eyesight when you look out straight, the horizon, that type of stuff. And then if you raise your eye up or your hand or whatever it is that you're measuring, it forms this angle right here. And that's called an angle of elevation. And this little blip here has a perfect description of it, right? It says, imagine you're looking straight ahead and you must raise or elevate your eyes to see the top of a tree. So when it says angle of elevation, that's what you need to picture. It is always inside the triangle and it's going to be down at the bottom. Okay, so find the angle of elevation of the sun when a 12-meter tall telephone pole casts an 18-meter shadow. So here's our telephone pole, right? Whatever they look like, or something. I don't know what telephone poles have on them, but whatever. So there's the telephone pole, and it casts this shadow, right, going out so far, whatever it looks like, because the sun is shining down over here. So the sun's shining down, it hits the telephone pole, and the telephone pole casts this shadow over here. And it tells us that the telephone pole is 12.5 meters tall. That means that's this guy over here. This guy is 12.5 meters high. Then it also says it has an 18-meter shadow. Well, this right here is our shadow. So that guy is 18. Now, what does that have to do with anything? Well, if you connect the top of the telephone pole to the top of its shadow, you have formed a right triangle, which means you can use any of our tricks that we've learned so far to solve for any other piece in that triangle. So what we're trying to find is this angle of elevation right here. We'll call it X. And you've got the opposite side and the adjacent side, right? This would have been the hypotenuse. Opposite and adjacent are involved, which means we have to use tangent. So the formula says tangent of X equals opposite over adjacent. So in this case, it's going to be 12.5 over 18. Now, if we're trying to find an angle, that means we have to do the inverse guy. So X equals the inverse tangent of 12.5 over 18. So that is, X is approximately 34.8 degrees. Remember, we're finding an angle right here. Don't forget to be in degree mode. If you're not, you're going to get some weird funky answers that just don't make sense. Angle of elevation should be positive if you're going from the ground and looking up. That can't be a negative angle. But that's how angle of elevation works. Let's try another one. Because we can actually apply this to different situations now. Application problems like this: parasailer attached to a boat with a rope 72 feet long. Angle of elevation, now we're going to talk about that. From the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. So estimate the parasailer's height above the boat. Let's draw a picture. You guys love my artistic ability. Draw a little bit down here. Okay, here's my boat. Now, parasailer, I don't know if any of you have ever done it or not, but they hang this rope from the end of the boat, and there's some guy with a parachute on flying up behind it. So the boat's driving along, and they go off on this in this parachute, and it pulls them behind the boat. It's actually pretty fun. All right, so that's the basic picture of it. Now, angle of elevation is if you take the starting point and you draw a flat horizontal line, then the angle from that horizontal line up to the line of sight, the thing that you're looking at, that's called an angle of elevation. And it tells us that that is 28 degrees. Okay. Next, it tells us that the rope is 72 feet long. Well, this right here is the rope. Now, how is that useful given what we were just talking about? Well, if you draw a perpendicular line down from that guy at the end of the rope to that horizontal line, we have formed a right triangle. Right? Perpendicular means right triangle. Inside here is 28 degrees. This is 72. And then the last part is, what are they asking for? It says estimate the parasailer's height above the boat. That would be this guy, which is x. Okay, just like before, in order to solve, to find that other side, given an angle, you have to identify what pieces you have. So we've got theta is 28 degrees. Looks like our hypotenuse is given. And what we're trying to find is opposite the angle. Okay, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA tells us that if I'm talking about opposite and hypotenuse, then I'm talking about sine. Okay, sine of theta is opposite over hypotenuse. Plug in what we know. Sine of 28 degrees equals opposite x over hypotenuse 72. Now, are we finding the hypotenuse? No. Then that means that we're actually just going to multiply by the number, both sides. So x is 72 times the sine of 28 degrees, which is about 33.8. My feet. No, you love my pictures. Let's try the next.